All right, so I thought I would spice things up by putting a picture of me on the front slide. I'll try to put a different picture of an archaeologist in action, using me as the key example. I'll start off with an identifiable one. All right. We're going to continue on with our discussion of excavation with a discussion of how we basically record data in the field. Now, your site director, we mentioned the different personnel. The site director, who's usually in an academic archaeology type research dig, will be the same person as the principal investigator, the professor who pitched the project. So I usually fill this role when we're in the field. But we all have a slightly different approach to doing things. But we all tend to use these basic kinds of things. You've got context sheets, which are sometimes called level forms. This is a basic form that has on it all of the things that excavators should look for. So and I'll show you an example of one as we come down the road. So I guess I don't need to say much about that right now. Plans, or also sometimes called a plan view. That's a basic map, a top-down map of the finds that each excavator makes. A section or a section map, sometimes called a profile, is a side view map, a view of like the side of an excavation unit. I'll show you some examples in just a second. We all have some kind of artifact collection system or catalog system so that we can record the finds of a site. And I'll discuss that as we move on. And when possible, we try to organize these data with computers. I pulled that last one out of the textbook because I would not say that is something that we all have in common. There's a lot of reasons not to use computers on a site. Not the least of which is that often you are in a remote location. Often the weather is bad when you're working. So you can't always depend on having a computer. Second of all, computers are fickle things and are subject to losing data. In my opinion, everything that's on a computer that's worthwhile should have a hard copy of it somewhere if you intend on keeping it forever, or at least a backup somewhere. And you can't always make backups when you're in the field using computers. So I like to record all of this stuff on paper, and then computers are used where appropriate. Potentially, data could be entered in the evening as a sort of a permanent storage device. But once you ultimately need your data on computers to be able to write papers on it and to analyze it with maps and GIS software and that kind of thing. So. Now, in terms of mapping and getting things into position, we're going to want to know where everything is with exacting detail. That three-dimensional position of an object is called its provenience. That's Provenience, provenience. So if I talk about the provenience of an object, that means, well, that's exactly where it was found. The most basic way of positioning your stuff on an archaeological site is with a tape and compass. When I say tape, I mean a measuring tape. Measuring tape and a compass. If you ever make a map of something, or if you ever want to make a map of something, and you want to get an exact, and you want to use, and precision makes a difference, the first thing you ought to do is establish a datum, a central point from which all your measurements can be taken. And once you have that, you can pretty much establish an imaginary coordinate system with, so many feet or meters north of my datum, or south or east or west. And then you can just use your tape and compass to calculate what those coordinates are. If you really want to get fancy, you can use polar coordinates and say, okay, my object that I found is 135 degrees away at 20 meters, and then but now we're getting into more complicated trigonometry, geometry, which brings up a good point. In archaeology, it's a really good idea to have a good handle on basic mathematics, geometry and trigonometry in particular. It's amazing to me that the university requires calculus level mathematics, but not those things, which are far more useful to most people. So trigonometry and geometry are what you need to establish objects in three-dimensional space. And people use those skills of trigonometry and geometry in all kinds of industries: construction, archaeology, geology. Pretty much all the ologies use those things. All right, so tape and compass. A theodolite is a non-electric version of the total station, which I mentioned before. Another term that I see them using in the text is EDM. That stands for electronic distance measurer. I use the term synonymously with total station. There may be some kind of technical difference, but a total station is a type of electronic distance measurer. The difference, I guess, is that the total station has a computer built into it that records all of your measurements. Whereas the theodolite, it doesn't use electronics. It's an old-fashioned survey instrument. And again, I would probably, this is so much faster, but they're expensive. And I'm just telling you that when you're in the field and you start using electronics, they cannot be counted on always. In getting the data out of this total station can pose a technical barrier. Whereas if you have a theodolite, you're doing everything manually, the old-fashioned way. You're writing all your measurements down in a book. The problem is that's very slow. So this is one place where if I had the ability to, I would bring the total station in, because you can take 1,000 measurements in an hour. Whereas with theodolite, you'd be lucky to take 10 or 15 measurements. So, well, you probably take more than that if you're really good at it, but 10 or 15 measurements. But they both look very similar. This is a total station, I presume, because I think this device down here is a data logger, and there's a cord running down to the data logger. But that just could be a handle or strap, in which case this would be a theodolite. Okay, so let's discuss the context recording sheet. If you ever participate in an archaeological dig, you will probably be faced with this or similar recording instrument. Each director may develop their own. There is not a standardized one, but the idea is that I mentioned before, in academic archaeology, you quite often have people who are not trained or have no previous experience doing archaeology working alongside professionals. In order to make it so that everyone collects the same kind of data, you just have a form that has everything on it that they need to fill out. Works very well. And it also, even for experienced people, it makes them record data that they might forget to collect certain kinds of data. And having a form is a nice way of making it easier for everybody. The purpose of this is to write down all of the information that the excavator has. Now, next week we'll talk a little bit more about the actual digging process. But everything that they excavate out, remember, is being destroyed. So any kind of notes that they want to take have got to be on this form or some other form, but this is typically what we're going to use. So we're talking about, when it says records of layers, we're talking about, if you excavate in layers, you're keeping all that data separate. The site stratigraphy refers to the subsurface geology, or pedology, which is soils. And these becoming very, very useful to us. So I'm writing up the archaeology from last season right now. And so I've got a stack of level forms or context record sheets that they're my complete record of what we did. So if you're a field director, it behooves you to check these things as people turn them in and make sure that they are detailed enough. Because a lot of time the excavators don't think it's important to write all the details, but they have to remember that it's all that we're ever going to have. I'm going to come back to this, and I'm going to talk about this real quick. This should have been up there. Look, I'm not going to ask you to fill out a form, so you don't need to know all this stuff. But I do want you to know the kinds of things that we're putting on here, because some of these kinds of things that we're recording, you're going to want to be able to discuss or talk about on a test. But I won't ask you to be able to fill out a form. Just a few of the things that I wanted to mention were, every site has a unique reference code, usually given to it by the government. GNJM 32 might stand for the county or the state that something's in, and then the site number. These things are all recorded with some government body, so we put that up there. The interpretation that this is a foundation of a house. Each excavation area is usually assigned a number, so that if I have 10 or 15 excavators excavating in different places, that each of their little areas might be given a number like 5 or 6. This would be two pits right next to each other. And I might have these things gridded off into a larger coordinate system. The whole point is this is telling me exactly where this excavation unit is. And I've asked them to write a description of the soil, and this is just an example of what they might have written. Sometimes, now in America they don't do this a lot, but I find it very, very helpful that when you're excavating in layers, and you have a layer of soil that's relatively easy to identify, you can give that layer a number, like 100, 101, 102, and record that somewhere. And then when you're excavating in the next test unit over, if your soil that you're excavating in looks just like that other soil, you could write, this is the same as 101 or 105 or whatever. That's what they've done. This is the same soil as this other test unit. And if you happen to know, like if you've excavated down 5 or 6 layers and you've numbered them all the way down, and know, for example, that layer 164 is stratigraphically higher than 105 in one test unit, then you could make a note of that right here. You could say it's below this or above this. Later means more recent. Sorry, that's confusing. But later means it comes after 164. And this is going to start to help you get a relative chronology of a site. So these are these things are very, very helpful. And the excavators know better than anybody about the soil that they're digging in. Other things, for example, when they're done excavating this level, they're going to make a map. That map gets a catalog number, which you put here, so I can associate those maps, which are a separate piece of paper, back with this. And we've talked about plan views and section views, so those will both be on here. I'll talk about colors in a second. The elevation of the site on whatever map system you're using, and your provisional time period you're giving it. This comes from a Roman era site, Roman phase 1, and then the initials and date of the excavator, so that if I have any questions, I can ask them. So these are the kinds of things that you're going to put on an archaeological level form or context recording sheet. Now, comments and interpretation, these are the opinions of the excavators themselves. If I have to, if I ask you, you're excavating something, you're excavating this Roman phase 1 test unit, or trench as they call it up here, and I say, well, what do you think is going on here? And the excavator can tell me what they think is going on. They might think it's a abandoned floor of a house, or they might think this is a cellar, or they might think that it's really disturbed because they found a lot of trash, modern trash in the test, whatever they think. Their thoughts. They put all these things here and help me remember, because I may not look at this for 5 or 6 months. So they help me later to look at and interpret what this is. So those are the kinds of things that I want you to have on these level forms. Okay, so this slide here didn't work, but let me point out what a few of these things are. This is your Munsell color sheet. Geoscientists, whether they're geologists or soil scientists or archaeologists, people who work in the dirt, they want to characterize the color of something. They have this soil booklet, which is just like a bunch of paint chips, really. And you flip through this and you try to find one that matches. So this one might be, this might be here or there, one of these two maybe. And this has a number associated with it, and you put that on your level form when you're describing your soil colors. There's an example. There's a girl here making a plan view map. Can't really see too well, but she's got a little square here that she's drawn, and she's recording this information down there. And she doesn't have a compass. She's using a tape measure. However many, I don't know, whatever this, I can't read that, but there's a tape going in both directions, and she's drawing a top-down view, same thing that they're doing over there. So these are the kinds of things that your excavators do to help make the investigator's job a little easier. I'll let you guys copy these definitions down. I put these up here because I didn't think that previous slide would work, possibly. We refer to the soil that we pull out of a test unit, the matrix. So the matrix is not a virtual reality that you live in and can be freed from with a blue pill. Or was it the red pill? Doesn't matter. That's not what it is. But that would be a clever answer if I gave essay tests. I can remember in grad school, I was asked to, I was writing essays on some anthropologists, famous anthropologists from the past. And I was supposed to identify Sorokin as a Russian anthropologist, but I didn't know that. So I put that it was Spock's father. Sometimes you can inject a little bit of humor into these things, and professors will appreciate you rather than bullshitting them, which they can see right through. Okay, so a matrix is the soil that we bring out, in which is precisely what we'll try to get a color on usually. It's this Munsell color chart. The context is, the way the textbook uses it, is the layer of soil in which artifacts and ecofacts are found, okay? And they call that the context. So your context record is your layer that you're digging in. But I would like to say that it also can refer to an object's relationships to other objects on the site. So the context of a bone might be that it's part of a burial. That's its context. And it's imperative to know the context of an artifact to interpret what it is. Because one artifact doesn't tell you what a site is usually. It's usually because of a number of artifacts and their relationships to one another that can tell us the function or purpose of a place or site. I mentioned before the provenience as an object's 3D spatial coordinate, and then I put or general position if exact position is unknown. Quite often, let's just say you're excavating and you're trying to find things where they, in place, but you shovel all your dirt into a bucket. You take that bucket over and you dump it into a screen and shake it through a screen to make sure that you didn't miss anything. And let's just say you find something in that screen, a nail or a coin, right? Now, you don't know where it came from, do you? You don't have its exact 3D position, but you know its general position. Its general position was it was found in this layer of this test unit. So whatever those coordinates were that you wrote, so that's its general position. And so when I talk about provenience, I'm talking about an object's position on the landscape, essentially, as to whatever specificity I can get. And then plan view, top down. Everybody got those? So those are some of the terms that you need to know and remember. All right, I already covered that. All right, let's give you some examples of some of these things I was talking about. This is an example of a section drawing, or sometimes called a profile. And you can see all of these people are doing the same thing. They're trying to draw not a top-down view, but a side view of what they've been excavating through. This guy here is tracing the layers that he sees with his trowel. I see all kinds of lines here. It looks like he's tracing a sand dune. But anyway, that's what he's doing. He's tracing it out so that when he draws it, he can, it'll be easier for him to draw. I see real clearly here that there's a sedimentary difference right here. I don't know what that means, but that's a real obvious change. You can have 3 different kinds of changes in your profile, in your section drawing. You can have sedimentary changes, where you're moving from one geological layer to another. Like this might be clay, and then this might be, I don't know, sand or sandy loam or something. And it's not a gradual change; it's an abrupt change. That is an important indicator that there's an important event taking place at this contact. It could have been a erosional event, or it could have been that this was deposited on top of something. But there's some amount of time represented between these 2 contacts. The other kind of layer you can get is a soil layer. Soil forms on sediment. So if this was a fresh bunch of sediment, and plants and things start growing on it, all that organic starts to get put down into the soil, and this will turn a darker color, and you'll have a soil change with depth. And so eventually you get down to the unaltered parent material, but the whole top part of this could be different shades of black and gray or whatever, and been put into that soil. And then the other layer we're interested in is, of course, a cultural layer. So you might have a layer down here that's where all of the artifacts are coming from, and that would be a cultural layer. So stratigraphy can be very complicated because you're describing all of these things, because there's going to be a soil that could go through all of it. The soil can be imprinted right on top of a cultural layer, which can be imprinted right on top of 2 different sedimentary layers. It's only been in the last 20 years, though, that archaeologists have routinely, some archaeologists have routinely gotten specialized training in sedimentary geology. And it's really been transformative in terms of helping to understand how archaeological sites are made, both geologically and culturally. So we really understand the earth a lot better now than we did 20, 25 years ago as archaeologists, which really helps sometimes. These people are just, this person drawing a piece of his or her profile there, and they have little artifacts pinned. This person's doing the same thing. So these are the kinds of things that each excavator will be expected to be able to do. Quite often, if you're artistic, you'll volunteer to do these things because it can be relaxing. But other times, everybody has to be involved. Here's an example of a complicated section drawing that has cultural materials as well as other matrices. So they've drawn on here the locations of artifacts, the ages that they have interpreted. This is a Roman era archaeological site, so they've interpreted all kinds of stuff. This is an old one from 1922, but I thought it was a pretty example. Where you find coins, you note where the coins were. You've got rubble from the interpretation is an altar. An occupation layer, this is your cultural layer. There's a cultural layer on top of this rubble. And then there's filling. This is other matrix that's been deposited on top of the cultural layer. Then there's another occupation layer up here. They have not marked any soil development, so there either isn't any or it's not relevant. They've determined that it's not relevant. Generally speaking, you can predict that the deeper layers are older than the top layers. That may seem intuitive. It's an important concept to remember as an archaeologist when you're excavating. That's why it's important not to try to mix things together. If you excavate down through 2 layers at one time, and you don't know where stuff is coming from, then you can't tell how old it is anymore. You just may have mixed 2 time periods altogether. Up here, you've got a date of 330 to 350 AD if it can be dated by the coins. And down here, this is dated at 254 to 73 AD, much older down here. So I find it interesting that down here you've got coins of 193 to 230 AD beneath it. That's going to tell you that this whole area is mixed up in here, because there's older coins down here below. I mean, the oldest coin, 73 AD, is up in here somewhere. So using coins to date stuff is problematic. But archaeologists try to do it occasionally. A better way to date this would be through radiocarbon dating, which we'll cover at some point. But radiocarbon dating was not invented in 1922, so it wasn't around. So they did their best with the tools that they had. Is that all I have? Holy smokes. All right. So we'll continue our discussion of excavation today. When we last left off, we were talking about natural versus arbitrary levels. This is a figure that was published in the textbook, actually, that is something that I would have liked to have drawn on the board. So here it is. It shows you the brown colors show natural stratigraphy. Along the right there, you've got strata A, B, C, and D. And this, say, is a sloping profile that's going down to the left there. Ideally, well, in each of these cases, the idea is that each A, B, C, and D each has a certain type of artifact or represents a certain period in time. And if you can excavate the natural strata, that would be preferred, because you would get all of the artifacts from one time period. When you excavate, and so those would be natural levels. If you followed the stratigraphy, you'd be excavating natural levels. When you dig an arbitrary level, where you're starting at the surface and you just dig straight down 10 centimeters, you can see that in level 1, you've got mostly strata A and a little tiny bit of stratum B. By level 2, you've got some of stratum A, some of stratum B, and some of stratum C. In arbitrary level 3, you've got a little bit of A, a little bit of B, and a lot of C. And in 4, you have a mixture of C and D. So in this particular scenario, it's obviously would be better to dig with natural levels. The problem is, when you first start excavating in an archaeological site, you may not know what the stratigraphy is. So as an excavator, you have to be trained to be aware of changes in stratigraphy, which can be very, very challenging to do. So I'm presenting you with an ideal situation, really. We want to talk about precision excavation. The author mentions the use of a total station. A total station is a survey instrument. You probably see construction people using it at the side of the road, or civil engineers. It essentially uses a beam of light or a laser bouncing off a prism to determine exactly how far away an object is from the total station. It also gets you an angle. So you have an angle and a distance to the object. And the significance of the total station is that it's all computerized, and so it calculates an XYZ coordinate for you on your grid system. In the old days, you would use a survey item like a transit or a theodolite, and all you would get was distance and angle, and you would use your math skills to calculate the coordinate. You don't have to do that anymore. It'll now give you an XYZ coordinate if you use a total station. Now, the advantage of this total station, one is that you can take a lot of measurements very quickly. And back in the old days, when you had to use a transit or a theodolite, you'd have to take each measurement, write it down, do the math calculations, convert it back to your XYZ coordinates, and go to the next one. With this thing, you can shoot 5 or 10 shots in a minute if you needed to. And it stores, of course, all the data there for you for download later, which I would say is its biggest disadvantage. I'm a fan of using as little high-tech technology as possible in the excavation environment, because if this data isn't written down somewhere, if something happens to your data, it's lost permanently. I feel like you have to have data that's written down. And it also is very helpful to understand how you're getting your data. And when you're taking measurements with a survey or a theodolite, even though you may not take very many measurements, because you're doing the calculations yourself, you can spot problems, and you become a lot more familiar with the landscape when you do it the old-fashioned way. Nonetheless, almost all archaeologists today use a total station to try to get millimeter precision for where everything is coming from. With this, they can record the location of every item that's found in situ. Because you can take so many measurements, it's really nothing to go and take a measurement off of however many flakes that you find. And when you're done, if you could have a very detailed record of exactly where everything is in relationship to everything else. For example, you could use the top side. You could record the top side of the artifact, the compass orientation of the long axis, and its slope and inclination, which is what you would need in the example of the Campi. I forget what's the name of that French archaeological site. Grotte de la Campi, something like that. When you were trying to identify whether the objects were imbricated or not, to see if they were water traveled, you could do that with this very, very quickly and easily. Well, I should add that even if you don't have a total station, each archaeologist who's excavating in a test unit should record where all of their objects are coming from, and they should record the XYZ coordinates from their unit datum. I don't think I've got a slide for this, so I should just go off topic here real quick and mention it. Last time I told you that the site has a datum, and the datum, that's the point from which all measurements are taken, or at least where they're all referred to. If you're excavating in a test unit, one of the corners of your unit is your test unit is your unit datum, and you can record all of your measurements in relationship to that unit datum. And then that way the project investigator only has to record the location of the test unit. So you get one measurement that shows you where the corner of the test unit is, and then all the rest of the measurements showing you where all the objects are in relationship to the unit datum. So we're going to talk about these different excavation methods that we sometimes use. Troweling, shoveling, small tools, machinery, sieving, flotation, soil sampling. These are all things that if we were doing a field school, these are the things that we would do. This person is posing for a photograph showing maybe a proper way to trowel. You trowel by scraping dirt off of the surface in very small increments. Some of you may have had experience with trowels before, something like this. This guy is demonstrating the improper way to excavate, which is putting your trowel straight down into the dirt and poking it in there. You do that, you have the chance of cross-cutting strata and damaging archaeological artifacts. And if you found a burial, for example, you poke right through the skull and scatter it around. So we have to chastise these little children here for using their poor method. Okay, I'm just kidding, really. It's a tough crowd. All right, shoveling. Look at this guy. He's excavating a test unit, it looks like, and looks like it's a half a meter. That's a half a meter test unit. These are horrible. Whenever the boss tells you to dig a half a meter test unit, it's much easier to dig a 1 meter. Just imagine how little space this person is going to have to excavate after they get down around 10 or 20 centimeters. Anyway, I'll have a nice straight hole going straight down. Hopefully he's working on a ranch and they can use it for placing a post when he's done. Nonetheless, this guy's using a shovel, and he's using a shovel right from the start. You don't have to use a trowel, and depending on what you think you're going to find, using a shovel, it's fine to dig with a shovel. There's kind of a misconception that all archaeology is done with toothbrushes and dental picks and that kind of thing. All the stuff that goes in your mouth, I guess. But in fact, archaeologists use whatever instruments are best suited for the task. This person's digging a test unit, and they don't know if there's anything there at all. This is actually on a survey, not an excavation. And they got to this point, and their research design requires them to excavate a shovel test every 50 meters along their transect. So there may be nothing there. So it would be very impractical to excavate with a toothbrush or even a trowel. So this person is digging a test unit. I would argue that it's probably even overkill to dig in layers. If you're just looking for presence or absence of an artifact, you could just dig it with a pointed shovel straight down. And then after you have found something, that's when you have to make the decision as to what tools are appropriate to use. For these guys, for example, this next pick here, this guy on the right is also demonstrating an improper technique there. It looks like he's about to stick his shovel, or already has stuck his shovel straight down into the dirt, and is going to be digging much deeper than he needs to. The girl in the back there is showing more appropriately how you should be scraping with a shovel, and you can see that the other test unit here is being excavated properly by scraping with the shovel. Now, in the event that they find something that could be disturbed or scattered with the shovel, they would probably switch to a trowel. Notice that they're putting all of their dirt in buckets. This is because the dirt will be taken away from this location and sifted somewhere else. Looks like they're working on somebody's lawn. So in order to keep it clean, a lot of archaeologists will sift their dirt in a single location with tarps, which is probably what you see here in the foreground. We do use small tools, but in this case, in both of these cases of these pictures here, you see that the archaeologist is dealing directly with in situ artifacts, artifacts that they don't want to move, because they want to get an idea of where they are in relationship to other artifacts. So after something has been found, if it's determined that understanding, exposing them in greater detail will yield more information, then you can switch to smaller tools. In fact, most archaeologists have a toolkit filled full of smaller tools like these here, pencils and wooden rulers, tape measures, a variety of things for cutting roots. I'll tell you this much: that person does have a root cutter in theirs. When we were excavating in Sweden last summer, for some reason, we didn't have any root clippers among us. And I swear we would have given $100 for a pair of root clippers. So if you ever go on an excavation or field school, bring root clippers, because they are a pain in the butt, because you can't just pull out roots, because that will also destroy and introduce all kinds of mixing in your test unit. If you just grab a root and pull it out, you can pull dirt in from the sidewalls or dirt from the floor or whatever. You can't do that. So have yourself a pair of root cutters, if at all possible. Believe it or not, some archaeologists will begin their search with heavy machinery, including a backhoe. Backhoe operators, some backhoe operators who are used to doing archaeology can actually do this quite effectively. Let me switch to this other picture here that shows you how they are just sort of scraping off the top layer. Again, this is not something you would want to do if you knew there was an archaeological site on the surface that you were trying to expose because you wanted to see what the spatial arrangement of artifacts is. This is something that you would do in a situation where you know the site is buried. And so in this particular case, they just want to scrape back the topsoil so that an excavator can then come in and work with it in closer detail. If you work for a contractor, a lot of archaeology is done by contractors. By that I mean, let's suppose they're opening a new store up here along the freeway. Before they can get all of their permits to do their work, they have to make sure that they're not disturbing any archaeological sites. It's a state law of Texas, and every state has similar laws, are that you can't use state money to destroy an archaeological site. So if there's if there's important archaeological site wherever somebody is working, if they have any kind of state funding or if there's any kind of state permits are needed, they have to check off to make sure that there's no cultural resources there. And the people who do this work are contractors, contract archaeologists. They do a lot of work. And contract archaeologists, they have a limited amount of time and a limited amount of money to do their work. So they are more likely to use a backhoe like this to expose a broad area because they don't have 6 months to do their work. They may only have 3 or 4 days to find out if there's something there. So they will do this, and they will have a monitor with them, 1 or 2 trained archaeologists who are observing what it is they're scraping, trying to see if they find anything. And if they find anything, they'll stop the excavation and they'll switch to different methods. In the event that they find something truly significant, that could halt the project completely. This happened once down along Buffalo Bayou in Houston. They were doing some work widening with a street right along the bayou, and they found a cemetery that had been forgotten. They started pulling up bodies, and they had archaeologists on site, and that ended up being a huge task, a huge ordeal, because in order to deal with it, they had to move the bodies. There's additional laws that allow them not to build over burials. And these burials weren't even that old. They were historic, probably from the 1800s. Moving on, all of the dirt that comes out of an excavation unit has to be sieved or sifted, as we say. Right? And that's because it's quite easy to miss things when you are digging with something other than a toothbrush. And since I mentioned, we only tend to dig with toothbrushes and toothpicks and whatnot when we have found something that we've deemed to be significant and we want to not move it. The rest of the time we're digging with trowels, shovels, or other small tools, or even a backhoe. However, there can be artifacts that are picked up in those methods. In fact, it's quite common to find most everything that, in sieves. So they take that dirt and they sift it in a screen like this. Is a very basic small screen, probably 1/4 inch, might be 1/8 inch mesh. They put all the dirt in there, they shake it, and they look for it, and they save anything they find. This is the dirtiest part of excavating, which is why I mentioned earlier those people working on the lawn, they probably are doing all their sifting in one location. They'll have a canvas or plastic tarp underneath, and then they can put, when they go to backfilling, which is, to fill the unit back up again when you're done, they'll take that tarp over there and try not to leave any messes. This person is out on survey, doing it using another type of back-breaking sieve that has no legs on it to carry that around. And when you're on survey and you do a test pit, you usually have to backpack or carry this stuff a long ways. So this person is using a handheld sieve. And it can be hard work. And when you're out there excavating or sieving, it can be tough. This is a nice setup here, a permanent location setup that would show you something that has a suspended sifter. And this is a lot easier on the back. So as a researcher or principal investigator, the person in charge of a project, you got to think about the health and safety of the people who are volunteering or working for you. And so it's always, in my view, it's always good to have some kind of system that is easy on the back, if at all possible. These are all contractors here. All right, then we get to flotation. Flotation is a specialized technique where you put dirt into a water system. In this case, a homemade system. There you see they've got a barrel, plastic barrel with a window screen mesh, which is probably 16th inch or 32nd inch mesh, and it's attached to the side there. And they put a cup or a handful of dirt in there, and they swish it around, and they try to find even finer particles. This actually, what she's doing there looks to me like water screening, not flotation. Let me explain the difference. Water screening is just a type of screening where you use water to help it go through the screen. So you're able to essentially wash the dirt away. And water screening allows you to get a much higher recovery rate than just sifting through the dirt manually. Flotation is when you are literally dumping some dirt in there and collecting what floats. So this picture here is actually probably water screening, but when you dump something in the water, if it floats, you're looking for organic material. You're looking for charcoal, seeds, and other organics that will float. If you are doing a study of, if you find a fire pit, for example, and you want to see if there's any kind of microscopic remains in there, flotation is a great way of collecting that sample. It goes right along there with the soil sampling. We'll come to that in a second. Let me look at this other picture first. This is also probably water screening, but you can see that this could also be flotation. You take your dirt, you put it in there, and you dunk it down and try to collect what floats off the top. But in this case, and in the previous case, they're also trying to save whatever the heavy fraction is as well. So they're doing both at the same time. I've seen some setups where what they do is they try to take air bubbles and they put bubblers at the bottom of a bucket. And the idea is to try to create a circumstance where the light fraction finds it easier to rise up to the top. So what they're doing here, you see, this is a real flotation right here for sure. That little bucket on the red bucket, they're putting water in there. They're agitating the sample, and then the water, the top of the water is going through a PVC pipe and out the side and into a sieve. So they're literally sieving up the heavy fraction is going to the bottom of that bucket. It's the light fraction which is coming off in the water, and they're collecting in that sieve. That's a good way of collecting a flotation sample. That's the low-tech way. The high-tech way, they sell these high-tech devices that kind of do the same thing. Another thing that archaeologists do is while this is under soil sampling, taking a soil sample, but let me first talk about what it is I'm showing to you. I'm showing you something called a Munsell color chart. And this is pretty much standard in archaeology. The archaeologists want to have one of these, and they try to describe the soil or sediments that they're excavating in. Color is one of the important visual attributes of dirt that can help you understand if you're digging in a different strata or not. So archaeologists need to become familiar with the dirt that they're excavating. So these people are trying to get a color. And it's essentially like looking at paint chips, except for this particular book, Munsell Soil Color Chart, is specifically made with lots of browns and reds and some yellows and greens that pretty much cover all the main likelihood of soil types that you're going to find. Now, soil sampling is a little bit different. While this person is just getting a color and therefore characterizing the soil, which they can just write that down, a soil sample is indicating that you want to do something with the soil. Things that you could do with the soil. For example, you could float it. You could also use it for you could send it to a lab and have it analyzed for pollen. Pollen is something that you're not going to be able to see with the naked eye, and you're not going to collect it through flotation. It's something that would have to be processed by a pollen laboratory. Archaeologists can learn a lot of things from pollen. Pollen tells you about the flora of the environment, typically. So if you're excavating in 3,000-year-old sediments, and you could be finding different vegetation regimes in the past. This helps you learn about the ecology of the area as it might have been 2,000 or 3,000, 4,000 years ago and whatnot. So pollen can be really helpful. Other things that they use soil sampling for could be collecting charcoal, could be looking at phosphate content. If you can imagine, if you're living in an area, say you're at a campsite, your campsite has a lot of campsites end up being dirty. They end up having a lot more charcoal. They end up having a lot of grease and grime. This ends up changing the soil characterization. The soil chemistry changes slightly. And phosphates are one of the things that they look for to try to identify old campsites and villages, because in occupied campsites, the phosphates tend to rise. So that's another thing you can do with your soil sample. And a lot of things you can do with the soil. There's also a lot of specialized kind of excavation. So I'll close with 5 or 6 examples, I think, of specialized excavations. When underwater archaeology, basically almost nothing I've told you, you just throw it all out the window, except for one thing here. You see that they have established a grid. They've established a physical grid because when you're working underwater, it's much harder to work with sort of an imaginary grid, if you will. They can't use a total station, so having a grid system like this helps them to find where they are and to make sure what they're finding is helpful. They don't tend to use any tools when excavating. They tend to use water they'll have like an engine that forces water out one end, and they can use it kind of like a water pick to try to blow away sand. And they're mainly looking for heavy fraction. You're looking for heavier items. Preservation is usually pretty poor underwater. However, when these objects have become buried by sand or clay or mud, they can be preserved. You got to be very careful if they are preserved, say wood preserved, that you don't blow on it too much with the water. So it's a very specialized situation. We do have a course in nautical archaeology here, although I don't think Dr. Mark covers underwater excavation methods. But as you can imagine, it's fairly complicated and time-consuming and very expensive. Here's a specialized situation. These are excavators at Pompeii, a very unique archaeological site where the Pompeii in 72 AD, I believe, maybe it was 73. Forgive me, give me 72 plus or minus a year. There was a volcanic eruption that buried the city of Pompeii in ash. It buried it very quickly. People were killed before it was buried due to, they believe, due to toxic gases in the environment and or choking on ash. Their bodies were buried. The bodies decomposed over some amount of time, eventually leaving cavities in the ash where they were. Archaeologists came along and determined that if they came across a cavity when they're excavating, and essentially a hole in the ground, if they filled it with plaster, they could find the outlines of the bodies of the people who died, and that's what these are. These are plaster casts of people who died in the ash. As they come down on these things, as they find where they might be, they fill them with plaster and then they excavate around them. It's a unique situation. Probably, I mean, I only mention it here, I guess, as an oddity because it's highly unlikely that the circumstances that would create this situation, probably 1,000 to 1. So, again, we talked about these the other day in class. You asked about bog bodies. That was you asking about bog bodies? You were asking about bog bodies? Somebody around here, there you go, asking about bog bodies. So I thought I'd show you guys a slide of what these bog bodies look like. Where you saw Otzi, the Iceman I showed you last time, he is all dried and since poorly preserved in some ways, even though his skin and his tattoos are still there. Bog bodies are even better preserved when you find them. These people were thrown into the bogs of Europe around the same time, 3,000 to 5,000 years ago. They get buried in the bog. Their bodies get preserved by the tannins and the peat, and then by the anaerobic conditions at the bottom of the bogs. The fact that there's very little or no oxygen at the bottom of the bogs. Hundreds of these have been found. This is a particularly well-preserved one called Tolland Man. It's incredible how lifelike they are, and to think that they're real people. This person, many of these victims, these people show evidence that they were killed before they were thrown into the bog. This person was found with a rope around his neck, for example. A lot of other people are found with their throats slit. There's so many of them in Europe that it's not believed that they are just victims of homicide, that there might have been some kind of cult or religious practice that was involved. Archaeologists, you probably don't have much, it doesn't take much thinking to understand why archaeologists would be the ones studying these bodies. But we talked the other day in class as we were ending about forensic archaeology. This is dealing with bones that are found that aren't old, that are maybe within the last 10, 15 years, typically homicide victims or murder victims. They can also be victims of natural disaster. Archaeologists were called in at the World Trade Center on 9/11. Archaeologists have worked at mass graves in Europe to try to help identify a genocide. It's really kind of a historical accident that archaeologists would be the ones to do this, or anthropologists in general, because of anthropology's long interest in bodies. Archaeologists and anthropologists have developed all these techniques for recovering them and preserving them once they've been recovered, and identifying. I mean, archaeologists are always identifying the demographic information about the people they excavate, male, female, how old were they when they died, what was their health, all sorts of things that archaeologists can learn from a body. We have a course called Physical Anthropology. If any of you want to take it, Physical Anthropology goes into a lot of this stuff on how to handle, how to interpret human remains. So archaeologists have become the go-to people when you're trying to excavate human remains. It's a potential job for people who graduate with a degree in archaeology. These are genocide victims in Europe from Armenia, a genocide that the nation of Turkey insists didn't take place. I guess that's all I have to say about that. Any questions? Comments?